Okay guys, welcome once more to another video again on our YouTube channel. So in today's video we are going to look at logarithms, okay, for the ordinary level mathematics. Okay, as displayed to you on screen, you can reach me on the YouTube platform via Mathematics Dreamland for Africa, or on WhatsApp via the telephone number displayed to you on your screen. Okay guys, as displayed, I decided to separate this topic, search indices and logarithm, into separate videos, because if I decide to combine them, if I was to combine the three topics, the video will be too lengthy and that might increase your cost of megabyte. Okay, so without wasting much of our time, let's get started. Okay, so we are going to look at logarithm for today's video. All right, what is actually logarithm? So let's define logarithm. The logarithm of a positive real number a to the base b is the power to which b must be raised to get a. Okay, that is, if b power x equals to a, then we define x as the logarithm of a to the base b, as displayed here. So if b power x equals to a, then x equals to log of a to the base b. Okay, so this relationship here is used to interconvert between exponential and logarithmic forms. Okay, so it's very important. So if you are moving, this is actually the index form, this is a logarithmic form. If you are moving from index form to logarithmic form, there is a procedure to do that. And if you are moving from logarithmic form to index form, there is a procedure also. So it's just to interconvert between them. Okay, all right, so there are some important things that we have to take note of in this topic. All right, so we have the logarithm is the reverse process of indices, as I earlier said here. So if you are moving from this side, if you are going to log form, it means you can actually still move from the logarithm form back to the index form. Okay, so the logarithm of a negative number does not exist. That is, the log of a to the base b does not exist if a is actually negative. So if a is negative here, this log does not exist. Okay, 4.3, we have log of 0 to the base b is not defined in R. Okay, means it is not defined in the set of real numbers. Okay, so 4.4, any logarithm without a base indicated is in base 10. So if the base is not indicated, it means that logarithm is in base 10, like here. So we have log of m, which simply means that since there is no base here, it simply means that log of m to the base 10. So if the base is not written, if you are given an equation where the base is not given, just know that that logarithm is in base 10. Okay, so let's look at some of the examples. Okay, we have write down the following in logarithmic forms. Okay, this is the point 1. This is number 1. 4 power 3 equals to 9. Okay, let's look at the solution. Okay, 4 power 3 equals to 9 implies that to the log form, oh sorry, there was supposed to be equal to 3 here, equal to 3, yeah, equal to 3 there. So for me to convert it to the log form, I'll have that a log of 9 to the base 4. Notice that is, let me give you some trick about this thing here, because it's actually disturbing many students. Okay, yeah, many students, even in the advanced level, to convert between exponential to log form or log form to exponential form. And you might encounter this in physics, chemistry, and in fact in most science subjects. Yeah, it's very important, mostly when you be doing data analysis in anyways, that's not really important. Okay, yeah, so that is it. All right, let's look at example 2. Okay, we have 1/5 raised to the power negative 3 equals to 25. Now, as I earlier said, it's only the base that is moving here. So 4 is the base. So notice that in the index form, 4 is the base, and in the log form, 4 is still the base. Okay, so and the log form must be equal to the power that the base was first of all raised to when the equation was in index form. Okay, so that is it. All right, here is the same thing. So this is actually the log form. So the log form will actually be equal to the power to which the base was raised to when the equation was in index form. Okay, all right, so that is it. Let's move to point number 3. It's the same thing. It's the same thing. So you see, 7 is the only base, the only base, and the 7 is the base is the only number that is actually moving. Okay, yeah, that is it. All right, and let's look at number 4. Number 4 is the same thing. So that is it. Power m, if you convert it, we have that the base is still there, which is m. All right, such conversions from exponential to log form and vice versa should be practiced. E.g., if we have k equal to log of 27 to the base 3, this is okay. Now we are actually moving from the log form to the index form. So you see that to the base 3, the base is the only one that is moving. So that is it. We have 3 power k equal to 27. Now notice that we can actually look for the value of k here. We can actually look for the value of k here. Okay, like I can make the basis to be the same, then I look for the value of k. All right, so let's look at it. So 3 power k be equal is it directly equal to 3 power 3. Since 3 power 3 is like 3 times 3 times 3 times 3, which is 27. Okay, so I've just expressed it in the index form. Okay, so since the two bases are the same, I will just find the value of k, which is means I will just equate the powers. That is why k is equal to 3. Okay, so since k equal to 3, therefore means that the log of 27, the log of 27 to the base 3 is just equal to 3. Okay, so that is it. All right, so let's look at the laws of logarithms. All right, for any real number, so we have to consider for any real number a, b, and k, where a is strictly greater than 0 and b strictly greater than 0, then law 1 says the log of ab to the power the log of ab to the base m is just equal to log of a to the base m plus log of b to the base m. So you notice that the two real numbers are multiplied there. Yeah, so you see it's a times b. Okay, so if you encounter problems of this nature where one of them is multiplied to the other, it means you actually look for you use the addition sign. Okay, so for law 2, the log of a divided by b to the base m is just equal to log of a to the base m minus log of b to the base m. Okay, yeah, so I will be explaining why I will explain the laws while I'll be solving the examples. Okay, so for law 3, we have log of a power k to the base m is just equals to k log of a to the base m, and provided k should be in R. Okay, yeah, k should be set of real numbers. All right, so this k here, so if we have problems of this nature, right, just take the power and then you bring it down like this. Yeah, you bring it down so that the power will be multiplied with the log. Okay, so for law 4, the log of m to the base m is just equal to 1. For example, you might have the log of 5 to the base 5. That will actually give you 1. Okay, yeah, so that is it. So let's look at law 5. Law 5 says the log of 1 to the base m is just equal to 0. It means provided here is 1. If here is any number, say 100, 1000, 200, whatsoever, the answer will actually be 0, provided the power here is 1. Okay, yeah, so that is it. So those are the laws. So we are going to use these laws now to solve some examples. Please, I can conveniently tell you that you should pay attention, because these laws, you are not actually using one law to solve one problem. You can use all them. You can actually use all both 5 laws to solve a particular problem, like just a single problem. Right? You can use all these laws to solve it. That is how logarithms are. Okay. All right. Let's look at some examples. Now simplify the following: log of 4 to the base 10 plus log of 25 to the base 10. Number 2, we have log of 14 to the base 2 minus log of 7 to the base 2. And number 3, we have log of 27 to the base 10 divided by log of 3 to the base 10. Notice that we have the subtraction sign here, which is actually log 2, and we have addition here, which is actually log 1. Okay, so let's look at the solution. All right, the log of 4 to the base 10 plus log of 25 to the base 10 is just equal to log of 4 times 25 to the base 10 by log 1. Okay, since here is actually plus, it means I'm to multiply the first two terms, this term and this term. Okay, yeah, so that is why we have 4 here and we have 25 here. So since it is addition sign, I'll just multiply them. Okay, so that is it. I will notice that 4 times 25 is actually 100, and therefore we have log of 100 to the base 10. I notice that we can actually write this 100 as 10 power 12, so that we can apply log 3. Okay, so at the end of the day, we are going to have that log of 10 power 2 to the base 10, and we can actually apply log 3 from log 3 here. We bring down the power, so that this power will be multiplied with this other with the log. Okay, so at the end of the day, we are going to have 2 log of 10 to the base 10. Okay, now by log, typo error, by log 4, we have that the logarithm of m to the base m is equal to 1. Therefore means that the logarithm of 10 to the base 10 is equal to 1, and therefore our answer is just equal to 2, since 2 times 1 is 2, because all this one here tends to 1. Okay, all right, so that is it. All right, so let's continue. So for example number 2 is it here. We have log of 14 to the base 2 minus log of 7 to the base 2. So since I have subtraction sign here, it means that I'm going to apply log number 2. Okay, and therefore it will be equal to log of, by log number 2 we have log of a divided by b to the base m is equal to log of a, which is it here, like saying log of 14 to the base 2, log of a to the base m, minus log of b to the base m, minus log of b, which is 7, to the base m, which is 2. Okay, that is why. So since I have it, this minus this other side of the equation, it means I'm going to use this other part now. Okay, that is why we have a divided by b here. So here I'm also going to have 14 divided by 7, okay, by log 2, and therefore we know that 14 divided by 7 is actually 2, so that we have log of 2 to the base 2. Now we can actually apply law number 4. Okay, log of 2 to the base 2 is actually 1. Therefore, our answer is just going to give us 1. Okay, so that is it. So let's look at problem number 3. For the problem number 3, we have log of 27 to the base 10 divided by log of 3 to the base 10, and this is just equals to, notice that we can express 27 as, like this are the previous slide, 27 as 3 power 3. Okay, and then we apply now law number 3. So you see here we're actually applying law number 3. Okay, but there's going to come a problem that we are actually going to apply about 3 or the 4 laws here. Yeah, so that is it. Now if I take this other side, right, I will have that 3 log of 3 to the base 10 divided by log of 3 to the base 10, and you notice that this log here can actually cancel with this other one. Okay, so if they cancel, we are going to have that our answer is just equal to 3. Okay, yeah, so that is it. All right, let's look at this part 4 here, this example 4, though I did not include it here, so I just decided to give it so that I can actually emphasize on some things. Okay, so simplify log of 2 to the power 3 plus log of 200 minus log of 16. So you notice here that the bases are not given. Okay, now you notice that anyways, let's just look at the solution. Okay, so that is it. Now notice here that here we can actually apply law 3. Okay, yeah, but notice that since the bases are not given, it means they are in base 10. Yeah, so it's like log of 2 to the power 3 to the base 10 plus log of 200 to the base 10 minus log of 16 to the base 10. Okay, so that is it. Now if we apply law 3, we are going to have that this 3 will multiply with this log, and we can condense these 200 here into 2 times 100, then minus 16. This 16 here, we can actually write it as 4 power 2, 2 power 4. Sorry. Anyways, let me. Okay, now this is it. So I've condensed it normally. Okay, so then here, so notice that I've applied law 3 here, and then I've applied law 2, law 1 here. Okay, and here I've applied law number 3 also. Yeah, so that is it. Okay, so we have 3 log 2 plus log 2 plus log 100 minus log 2 to the power 4. Okay, notice something here, right? Here yes, actually log 2 times 100. Okay, and then since it is multiplication, I'll apply log 1 for me to use. This is our log 1 here, so it means it will be log of 2 plus log of 100. Now this log of 100, I can actually write it as log 10 power 2, so that the 2 will multiply with the log. Okay, so at the end of the day, we are going to have that. Now we are going to have that 4 log, actually it was supposed to be 2 here, 4 log 2 here, it was supposed to be 2. Let me correct it. It was supposed to be 2 here. Sorry, it's not easy. Yeah, there was supposed to be 2 there. Okay, so it was supposed to be 4 log 2 plus 2 log 10 minus 4 log 2. Now notice that I've applied law number 3 here, so I've sent down this 4. Okay, that is why I have 4 log 2. And then here, what have I done here? So it means that here, since I take 10 raised to the power 2, so it means if I send the 2 down, I'll be left with 10 here. That is why I have log 10 here, and then the 2 will be multiplied with the log. Okay, so that is it. Now you notice that for this 4 here, you notice that 3 log 2 plus log 1 is like saying 3 plus 1, which is 4, because this is log 2, this is also log 2. But here there are 3 log 2s here, why here there is only 1 log 2. So if we add them 2, we have 4. And then we notice now that 4 log 2 plus 2 log 10 minus 4 log 2. This 4 log 2 we minus this other 4 log 2. Okay, so at the end of the day, we are going to just we'll be left with 2 log 10. And then you notice that since the base is not given, it means that the base is in base 10. Okay, so and then we apply law number 4. So for law number 4, since the basis, log 10 to the base 10, from here log m to the base m is equal to 1. It means that from here log 10 to the base 10 is just equal to 1, and therefore 2 times 1 will give us 2. So finally our answer is just 2. So this is a hint here. Since log m is equal to log m to the base 10, and so log 10 to the base 10 is just equal to 1, and this is a 1 here. Okay, so that is it. All right. Okay, so let's continue. So we are going to look at the change of base formula. So this change of base is very important in problems where the bases are actually different. Okay, so let's look at what this change of base formula is talking about. All right, so suppose we wish to change log of c to the base a to logarithm containing a and base b. So it means here we have to change such that we have a logarithm containing a and base b, so not base a again. Okay, so let's look at how we can do it. All right, so here we assign a variable, say x. So we let x be equals to log of c to the base a. Okay, so and then if we let x to be log of a, log of c to the base a, therefore means we can convert this. This is a logarithmic form. We can actually convert it back to the index form. So this is it in the index form. Okay, Now if I convert it to the index form, now I can take log on both sides. Now note that when taking log, we have supposed that we want to change log of c to the base a to a logarithm containing a and base b. Means the log that you are going to take on both sides of the equation should contain the base b. Okay, that is why we have, now if I take log here to the base b, I'll have log of a power x to the base b, since this is the required base. Okay, and then in the other side to also have log of c to the base b, since b is the required base. Okay, all right. So at the end of the day, we are going to have that since this is the exponential form, and since this is the logarithmic form, if we apply the laws, okay, according to law 3, so this x will come down here. Okay, and if that happens, we have x log of a to the base b, which is equal to this other side, which is log of c to the base b. Okay, now we can divide all through to make x the subject. Okay, so if we divide all through, at the end of the day, we are going to have that x equal to log of c to the base b divided by log of a to the base b. Okay, but actually we actually know that what is our x? Our x is the log of c to the base a. Okay, and therefore hence in general the log of c to the base a is equal to log of c to the base b divided by log of a to the base b, since b is a required base. Okay, yeah, so that is it. All right, so let's look at some of the examples on that change of base. Okay, convert log of 2 to the base 3 to base 10. All right, so base 10 here is our required base. Now if I may try to explain it using this concept here, right? So since our base 10 is a required base, it therefore means that we have log of 2 to the base 3 being equal to log of 2 to the base 10 divided by log of 3 to the base 10. Okay, so let's just look at the solution. Okay, now that is it. I've just explained it here, but this is, I want to take it step by step. Okay, so if we let y being equal to log of 2 to the base 3, right, according to this procedure here, is the same thing. So if we let y being equal to log of 2 to the base 3, it therefore means that this is the logarithmic form. So if we convert it to the index form, we are going to have 3 power y being equal to 2. Now we can actually take log on both sides. Okay, so if we take log on both sides, we take log. Now notice that we are changing to base 10. Okay, so it means we are going to take log of base 10 of both sides of the equation, and therefore means that if I take log of base 10 here, I'll have log 3 power y to the base 10 being equal to, I take log this other side to log of 2 to the base 10. Okay, so now I can apply law 3 according to the previous slide. I can apply law 3 such that this y will come down here. Okay, so at the end of the day, I'm going to have that y log of 3 to the base 10 being equal to log of 2 to the base 10. Okay, yeah, so I can actually make y not the subject. So if I make y the subject of the formula, and this is actually very important too, so I've uploaded a video already on subject of formula, so you can go and watch the video talking about subject of formula. Okay, so that is it. So but I actually know that my y here, this is my y is actually log of 2 to the base 3, and this is it here, but y equals to log of, okay, no, this is, oh, that should be a typo error, but y equals to log of 2 to the base 3, since that is my y, right? So it means that the log, which is my y, the log of 2 to the base 3 will just be equal to log of 2 to the base 10 divided by log of 3 to the base 10. So I decided to do it step by step because they can ask you that you should show your working in the exam. Okay, because you cannot just come here and just switch it just like that. Yeah, but it's actually still helpful. But I just decided to give the required procedure. Okay, all right, so that is it. Okay, let's look at our example 2. So solve for real x. Solve for the real values of x in the equation. Log of x to the base 2 plus log of 2 to the base x being equal to 2. Now, I notice that 6x is actually unknown. So it means I'm going to change this base x to base 2. Okay. So let's look at the solution. Alright, so that is it. Now, since I'm converting this x here to base 2, it means I'm going to work on it. It means I'm working on the log of 2 to the base x now here. So I've just applied this law here. Okay, I've just applied the law. Okay, so that is you notice that here is x. This x here is just like my a here, and this 2 is just like my c here. Okay, since I'm changing it to base 2, it means this b here will be my 2. Okay, this b will be my 2, and therefore I'll have that log of 2 to the base 2 divided by log of x to the base 2. Okay, by applying this law here. Okay, all right, now changing to base 2, because since base 2 is actually my required base, that is why I'm changing this log of 2 to the base x. I'm changing my x to base 2. Okay, all right, so that is it. Now notice something, that if we apply law number 4, which says that the logarithm of m to the base m is actually equal to 1, therefore means that the log of 2 to the base 2 is equal to 1, and therefore at the end of the day we are going to have that log x to the base 2 plus 1 over log x to the base 2 being equal to 2, and then from here we can multiply everything here by log x to the base 2. Okay, it means we can multiply by log x to the base 2, and then we multiply here by log x to the base 2, and then also multiply here by log x to the base 2. Okay, so at the end of the day, if we multiply this side, we have log x to the base 2 all squared. Then if we multiply this one by log, if we multiply this 1 by log x to the base 2, right, we are going to have that the log x to the base 2 will cancel this other one in the denominator, but this other side it will stay this other side, since there is no log x to the base 2 that can cancel. Okay, so at the end of the day we are going to have log x to the base 2 all squared plus 1 equal to 2 times log x to the base 2. Okay, so I can actually send this one inside here. Yeah, this one inside. So this is actually a quadratic. Okay, now you can solve it by formula method or by factorization. It depends on you. All right, so this is what we are going to have. If I send this one inside, right, I'll have log x to the base 2 all squared minus, since here it is actually plus, so if it crosses this equality sign, it will become minus. Okay, that is why we have a minus 2 here, but this one is actually positive since it is still in the other side. Okay, all right, so you can actually go and watch the other video on subject of a formula. Okay, this is where I explained there when a term crosses the equality sign. Okay, yeah, so actually this is a quadratic that you can solve it by a formula method or by factorization. So now here I can just factorize it, but for simplicity let me assign a variable. Okay, so if we let m to be equals to, oh, it was not supposed to be m here, anyways, so here was supposed to be t, actually not m, so here was supposed to be t. Yeah, if we let t being equal to log of x to the base 2, therefore means that if I see anywhere I will see log of x to the base 2, right, I will replace it with t, since t is equal to that. Okay, yeah, so that is why I have t squared minus 2t plus 1 being equal to 0, and by factorizing we obtain two values. So this is I'm going to use factorization method, but you can still use formula method there. It depends on you. So by factorization method, t will be equal to plus or minus 1. That is t equal to 1, because the logarithm of a negative number does not exist in the set of real numbers. That is why I neglected this negative number. I took but just the positive one. Okay, so that is it. All right, so since t equal to 1, right, so we know that our t is actually log of x to the base 2. So but t equal to log of x to the base 2 implies that the log of x to the base 2 will be equal to 1. So notice something here, that this is in the log form. Okay, so we can find x by changing this from the log form to the exponential form. Then we'll look for x. Okay, so if we change it, we have that this 2 here, as I earlier told you, is just this base that's moving. So if this 2 crosses this other side and being raised to the power 1, x will be left alone. Okay, and therefore x will be equal to 2 power 1, and anything raised to the power 1 is the same thing here. Therefore x equals to 2. Okay, so guys, this is actually the end of the video. So I recommend that you should like the video. Please subscribe, don't forget to subscribe to it, and also share to your friends, especially those of you preparing for the GCE exams. Okay, all right, thanks for watching once more.